वेलकम स्टूडेंट्स, आपका यूट्यूब चैनल शंकर कोचिंग में स्वागत है। मैं प्रोफेसर प्रेम शंकर आज 11th क्लास के स्टूडेंट्स को एनसीईआरटी बुक से चैप्टर नंबर 5 कॉम्प्लेक्स नंबर एंड क्वाड्रेटिक इक्वेशन पढ़ाऊंगा। आप इस वीडियो को अंत तक देखें। अगर मेरा ये वीडियो आपको अच्छा लगता है तो प्लीज लाइक करें, सब्सक्राइब करें और दोस्तों के साथ शेयर करें। चैप्टर 5 we have chapter 5 complex number and quadratic equation. We will discuss the things one by one. Like we have the first one is introduction. Then we have the algebra of complex number. Then we will discuss the operations. Then power of iota, I, and then the square root of negative real number. Then we will discuss Argent plane. In the Argent plane, we have the modulus, conjugate, then polar representation, and lastly, we will discuss the quadratic equation. See, we can find the solution of equation like we have x minus 1 is equal to 0. X minus 1 is equal to 0. Then we can say that this x is equal to 1. Similarly, if I have the x square is equal to 4, then the solution of x is equal to how much? It is your plus minus 2. Similarly, suppose I have one equation x square plus 1 is equal to 0. Then it has no any solution in the real number. Okay, so with this value will be, you will find that this is x is equal to nothing but it is your under root of minus 1. The under root of minus 1. So this under root of minus 1, it is not a real number, so we call this as a complex number, and this is we denote as a iota or I. In the similar case, let's suppose I have a quadratic equation is there, ax square plus bx plus c is equal to 0. Let's suppose the quadratic equation is like this. Then the discriminant of this equation d is equal to how much? If it is b square minus 4ac, b square minus 4ac, and if that is what? That is the less than 0. If it is the less than 0, then the solution is not in the real number form. It is in the imaginary form. Okay, so the solution is not possible as a real number. Okay, so we can say that under root of minus 1, that would denote it as a I or iota. So this is the complex number. So a number a plus iota b is complex number. That is what? Z is equal to a plus ib. Z is equal to a plus ib. So this is the representation of the complex number where this a is the real number and b is also the a and b both are the real number. Okay. For example, let's suppose I can take z is equal to 3 plus 4i. 3 plus 4i. So this is what? This is a complex number. So this 3 and 4 both are the real number. So I can say that if the z is the representation of the complex number, then the real z, what is the value of real z? That is equal to a, and what is the imaginary z? That is equal to v. So this is all about the introduction part of the complex number. Now we will see the algebra of complex number. In the algebra of complex number, we will discuss first the operations. In the operations, we will discuss 4 things: addition, multiplication, difference, and then division. Okay. Now, first of all, I will take the addition. Okay. So, in the case of the addition, let's suppose I have this. I want to discuss first the addition. Okay. So in the case of the addition and multiplication, we'll discuss both at a time, and then lastly we'll take the difference and division. So for the case of the addition, let's suppose I have two complex numbers. Let's suppose one is the z1 and that is equal to a plus iota b. And then suppose we have the another one that is z2, and this z2 is nothing but this is your c plus iota d. Let's suppose I want to find the addition. So for the case of the addition, the z1 plus z2, if I add it, z1 plus z2, so this is equal to how much? This is equal to your a plus c, iota is common, d plus d. So in this way, if the two complex number z1 and z2 is given, then I can say that the z1 plus z2 is nothing but it is a plus c iota b plus d. Now we will see the few property. We will see. The first one is the closure property. Closure property means what? If I will take any two complex number, if I add it, then its value will be also a complex number. So that is called the closure property. Now the second one is what? The second one is your commutative. For the commutative property, that means if I have a two complex numbers z1 and z2, then z1 plus z2, and if I reverse it and then add it, so the value will be same. So z2 plus z1. So this indicates this is the commutative property. Now next you can the associative property. Associative property. In the associative property, let's suppose I have three complex numbers z1 and z2, z3. So that means for z1 plus z2 plus z1 plus z2 plus z3, that is equal to what? That is equal to z1 plus z2 plus z3. So this is the associative property. Now one thing is there, that is called additive identity. Number fourth one, that is what? Additive identity. Additive identity in the complex number, that is the value 0. That is the value 0 is called what? The 0 is called the additive identity. Means if I take any complex number and I added 0 there, there will be no change in the complex number. So that indicate what? That indicate that 0 is the additive identity. Let's suppose I have z is the complex number. Suppose I add it here, 0 I will add it. So what will the value? The value is again equal to z. So this is your additive identity. Now one more is there, that is what? Additive inverse. Last one is what? Fifth one, what is the meaning of additive inverse? Additive inverse. What does it mean? Additive inverse means if I take one complex number such that if I add it, then I get the additive identity. Means I will get the 0. So obviously, if this z is the complex number, suppose z is a complex number. So if I add it here minus z, So I will get it what? I will get the 0, that is equal to, I will get the additive identity, that is 0. So this 0 is called the additive inverse. Okay. So this now the next one is addition, then we will discuss the multiplication also. Okay. So in the case of the multiplication, let's suppose I will take the multiplication case. Okay. In the multiplication case, let's suppose I have this two complex number, that is z1, and this is equal to your a plus iota b, and z2, let's suppose z2, this is equal to c plus iota d, Now, if I want to multiply this two complex number, that is, I want to find what? I want to find z1 into z2. How I will find it? So z1 and z2, if I take it, so what is the value? Its value will be your AC minus BD, then plus I, and this is your AD plus how much? AD plus BC. So this is the value of the Z1 into Z. Now in the multiplication case also we will discuss all these closure, commutative, associative, and this is additive identity. Better we will take the, in this case, multiplicative identity. Here it is the additive inverse, and now we will see the not the additive. We will see in this case multiplicative inverse, and lastly we have one distributive. So one by one I will discuss all this. So let's suppose I am taking the first one. That the first one is I am taking closure property. So what does in the case of the closure property means? If I will take this two complex numbers z1 and z2, if I multiply it, then again we will get what? Again we will get the complex number. So that indicator that this is true for closure property. Now then the second one you will see the commutative property. Second is your commutative property. In the commutative property, here it is what? Z1 plus Z2. In the commutative case, suppose I am taking the multiplication case, then it is simply what? That is what? Z1 into Z2 is equal to your Z2 into Z2. So true for, it is this multiplication is true for commutative property. Okay. Now come to the third one, that is the associative property. Third one you will see. The third one is your associative property. So in the case of the associative property, let's suppose I have three complex numbers, Z1, Z2 and Z3. So I have taken the sign of addition. But in this case, we will take the multiplication case, we will take the sign of addition. So it is multiplication. So it is what? Z1, Z2 into Z3 is equal to nothing but it is equal to Z1, then it is Z2 into Z3. So this is the means what? Means if I have three complex number, so Z1 to Z2 into Z3 is equal to Z1 into Z2 into Z3. So that is the associative property. Then the next one is what? Additive identity. So here we will take what? Here we will take the multiplicative identity. Multiplicative identity. So the only thing, multiple identities is what? It is your here it is multiple additive identity is 0. But here it is multiplicative identity is how much? It is value is 0. Not 0, it will be 1. That means what? That means if I multiply any complex number with 1, any multiplied by 1, then we will get again the value is z. So we call it, this is the multiplicative identity. 1 is the multiplicative identity. That then we next come to the multiplicative inverse. Here it is a additive inverse. Here on the last we will see the multiplicative inverse. Multiplicative inverse. Multiplicative inverse. Multiplicative inverse. Multiplicative inverse means what? Multiplicative inverse means simply if I multiply one complex with another complex number, we will get the multiplicative identity. That we must get the value 1. Okay. So let's suppose I have z is one complex number. So if I multiply it by 1 by z, so we will get what? We will get the 1. So 1 is what? So 1 by z is what? 1 by z is the multiplicative inverse. Okay. So let's suppose I have a z I have, and I want to calculate the multiplicative inverse. So how will you get the multiplicative inverse of this one? Okay. Let's suppose this z is equal to what? Z is equal to a plus iv. Okay. I want to calculate 1 by z. So 1 by z is equal to 1 by a plus iv. So 1 by z is this much. And if I solve it means what? Solve it means you rationalize this into a minus iv divided by a minus iv. So what is the value of 1 by z? The value of 1 by z is simply what? Simply it is equal to, in the denominator you will get what? A square plus b square. And after rationalizing, we get here a minus iv. So the value of 1 by z is equal to how much? A divided by a square plus b square minus bi divided by a square plus b square. So this is what? This is the multiplicative inverse. Okay. Now the next one is what? Difference and division. Difference and division. Okay, so we'll say the case of the difference. Next, this is also operation difference. So what is the value of difference? Okay, so see in the addition I get the z1 plus z2. I got it here. Z1 plus z2. So if I want to take the difference, so in the case of difference, this is equal to as the addition, but we have changed the sign. So z1 plus minus z2. This is the case of the difference. This is the difference. Okay. Now the last one is what? Last one is division. Okay. Last one is division. Suppose I am discussing here. I will discuss the division. Division. Last one is division. Let's suppose I have the two complex number z1 and z2. So z1 and z2. Let's suppose z1 and z2. This is the two complex number. So how we define the this division? So division is nothing but this is equal to z1 into 1 by z2. 1 by z2. So that indicate what? That indicate division. Okay. But mind it, z2 this is not equal to 0. Okay. z1 by z2. So z1 into 1 by z2. So that indicate what? Division. 1 by z2. Okay. So this z2 must not equal to 0. Mind it. For solving this z2, we have to take the rationalize this. After rationalizing, and then we will use the z1. So this is all about the division. So this is the case of the operations, and we have discussed. addition, multiplication at a time, and difference and division at a time. Now, in the case of the algebra of complex number, we had already discussed these operations. Now we discuss identities, then power of 5, then square root of a negative real number. We'll discuss one by one. Operation already I discussed, like addition, multiplication, then difference, and then division. Now we will see this identities. Okay, in the case of this identities, we will discuss one by one. So let's suppose z1 plus z2 is a 2 number. Okay, so from the formula, we are knowing what a plus b whole square. Now this is equal to your a square plus b square plus 2ab. And let's suppose I put it here minus sign, a minus sign. So I will get here also minus sign. So let's suppose z1 and z2 are the two complex numbers. So what is the value of z1 plus z2? So z1 plus z2 whole square. This is equal to your z square, z1 square plus z2 square plus minus 2 into z1 into z2. So this is the one identity. In the similar way, let's suppose I will take a plus minus b whole cube. What is value? It is your equal to how much? It is equal to your a cube. This is a cube plus 3, a cube plus 3a square b plus 3ab square, and this is your plus how much? Let's suppose it is how much? Plus b cube. Okay. Let's suppose I put it here minus sign, so here I will get the minus, it will be already plus, but here I will get what? Here I will get the minus sign. Okay. So let's suppose z1 and z2 are the two complex number. Then what is the value of this one? So this is simply z1 plus minus z2 whole cube. This is equal to your z1 cube plus minus 3 z1 square z2, and here it is the plus 3 z1 into z2 square minus, okay, the plus and then minus dq is there, so that is your z2 cube. So this is one more identity. So I'm taking one more identity is like a square minus b square. So it is equal to your a minus b into a plus b. That is what? That is your z1 square minus z2 square. This is equal to z1 minus z2 into z1 plus z2. So these are the identities. As I had what I had done, I had taken the algebraic identities and then I put that z1 and z2. Now let's suppose I want to discuss of the power of I. Power of I. Power of I. Okay. Let's suppose I am taking what? I am taking I square. I square I am taking. What is the value of I square? I square is nothing but it is simply equal to minus 1. I square is minus 1. Similarly, if I take the I cube, so I cube is equal to how much? This is your I square into I. I square into I, so it is equal to how much? It is equal to minus I. Similarly, I will take the I4, I to the power 4, that is equal to how much? I cube into I. So what is the value of I4? I4 is equal to how much? This is equal to how much? I cube is equal to minus I. So minus I into I. That is how much? I square. So this is your 4. That will be 4. Similarly, I have I5. I to the power 5. So it is equal to how much? I4 into I. So I5, I4 is equal to 1, so it is equal to I. So this is equal to I. So let's suppose k is any integer. So what is the value of I4k? If this k is any integer. So what is the value of I to the power 4k? Is nothing but is equal to 1. Okay, similarly I have I to the power 4k plus 1. I is equal to 4k plus 1. So this is equal to how much? This is simply equal to I. Similarly, I have I 4k plus 2. I 4k plus 2. So what is the value of I 4k plus 2? Obviously, it is how much? It is equal to minus 1. Similarly, I have 4k plus 3. What is the value of ik 4 plus 3? It will be how much? Minus I. What I am doing here? I am taking I 4k. The 1. So into I is just I square is just minus 1. I cube is minus. This is minus I. So in this way, I can calculate the power of I. Now, now we will see what the square root of negative real number. The square root of, suppose I want to discuss what I want to discuss. The square root of negative real number. The square root of negative. I want to discuss this last one. Already I discussed identities. I have discussed, or of I also I discussed. This also I discussed. So, what is the value of the square root of this negative real number? Let's suppose I'm taking one simple real number, minus 1 I'm taking. So suppose minus 1 is this the negative real number, and I want to take the square root. So I will take the square. If I take the square root of this one, so this is square root of this one is how much? This is equal to I. Because I can take it in this way, root 1 into root minus 1. So that is equal to your, this is equal to root 1 is 1, root minus 1 I times, so this is equal to 5. Now suppose I want to take the root of minus 3. What will the value? It's equal to how much? Root of 3 into root of minus 1. So this is your root 3i. So this is the square root of the any negative real number. Let's suppose in general I take this one. I'm multiplying the two this number. One I'm taking the case of the positive real number, another case I'm taking the negative real number. So what is the value of root a into root b? Root a into root b, just this is equal to your root ab. So this root ab is there. So I'm taking two cases. One case I'm taking when this a and b is the positive real number, and when a and b is the negative real number. See, when you will take the root a into root b is equal to root a and b, where ab is the positive real number. So it is true for positive real number. But this root a into root b I am taking, this is not equal to root a ab. This is not equal to root ab. When this a and b is the negative real number. Is it a negative real number? I'm taking the simple case. I'm taking the root minus 1 into root minus 1. How much it is equal to? If it multiply this one, so we will get what this is equal to how much? Minus 1. Okay. This is equal to minus 1. So if I take into a into b, so how much it will be? A into b is how much? So this root a into b, that is minus 1 into minus 1. So this is equal to 1. So we can say that when a and b are the negative real number, then root of a into root of b is not equal to root ab. Now Argent plane. In the Argent plane we have the modulus, then conjugate, then the polar representation. So what is the Argent this plane? Actually we have the ordered pairs like with a real number x and y. X and y are what real number, and it is the ordered pairs. Okay. And this x and y has the what? It has the unique point in xy plane. Suppose we have the mutually perpendicular lines, and these lines are known as x-axis and y-axis. X-axis and y-axis in the Argent plane are called the real axis and the imaginary axis. So x and y the ordered pair, and we have the mutually perpendicular lines. This is mutually perpendicular lines. And with the x-axis is the real axis, and this y-axis is the imaginary axis. We want to Argent plane, this Argent plane. Okay. This is x-axis, y-axis. X-axis is the real axis and y-axis is the imaginary axis. So let's suppose I want to take few of the points like 2 plus 4i. I'm taking one, 2 plus 4i. Then next one is I'm taking minus 2 plus 3i. Minus 2 plus 3i. So this, suppose this is the point A, this is the point B. Similarly, I have one more point C. This is equal to 0 plus I, 1i. 0 plus I. And one point is minus 5, minus 2i, minus 5, minus 2i. I want to represent this on the Argent plane. Okay. So I will divide it by what? So suppose these are the division 1, 2, 3, 4, 5. Here it is also 1, 2, 3, 4, 5. Here it is also 2, 3, 4, 5. Here also 1, 2, 3, 4, 5. These points I want to represent in the Argent plane. Okay, so how I represent this one? 2 plus 4i. So this 2 plus 4i, it is where it will be? It will be situated in the first coordinate. Okay, so this is 1 and 2, and here it is 1, 2 and 3. So this is point. This point is how much? 2 plus 4. So 2, 1, 2, 3, 4. So this point is your A point. Similarly, I have B point, minus 2 plus 3i. Obviously, this will be in the second coordinate. So this is minus 2 and plus 3i. This is somewhere here. This is point B. Then C point is 0 plus 1i. So this is on the y-axis. This is point C. And last point D is here, minus 5 and minus 2i. So that is in the third coordinate. So where would the minus 5? So this is 1, 2, 3, 4, 5. Minus 5 and minus 2i. This is somewhere here. This is point D. So this is the Argent line. Now we will discuss the modulus and then the conjugate. Modulus and conjugate. So first I am taking what? First I am taking the modulus. First I am taking the modulus. Modulus. Okay. Suppose any complex number you have given z is equal to a plus ib. Z is equal to your a plus ib. Then what is the modulus of z? Modulus of z, what? Modulus is represented by this one. This is equal to your under root a square plus b square. This is your modulus of z. If formally we will see, like suppose first one I am taking, first I am taking. Let's suppose I want to find what is the value of this. If formally I will see mod of z1 and z2. This is nothing but this is equal to mod of z1 into mod of z2. Mod of z1 into mod of z2. Similarly, suppose I want to find second mod of z1 by z2. This is equal to mod of z1 divided mod of z2. So this is what? This is the formula of the case of the modulus. Okay. Now let's suppose I want to find this is the case of the modulus. Now suppose I want to the case the next one is the conjugate. Let's suppose I want to discuss this conjugate. What is the conjugate? Conjugate. So how I find the conjugate? First of all, what the conjugate means? Conjugate means what? Suppose z is any complex number. Okay, z is here any complex number a plus ib. So what is the meaning of conjugate? Conjugate will be represented by z bar. Z bar. So it is equal to how much? Z bar is equal to nothing but this is your a minus ib. This is your z bar and this is equal to your a minus ib. Let's suppose I want to find what is the value of 1 by z. So on the 1 by z I am interested in finding what the value of 1 by z. So this 1 by z is equal to how much? This is your z inverse. So let's suppose z inverse is equal to how much? This is your this is 1 upon how much? A plus ib. A plus ib. 1 by z is equal to 1 by a plus ib. So if I rationalize this, I will get a minus ib divided by a minus ib. And the value of this one, this is nothing but your a minus ib divided by a square plus b square. Okay. So what is the a minus ib? So a minus ib nothing but this is the conjugate of z and a square plus b square. So that is nothing but that is your z square modulus of z square. Okay, modulus of z square. So this I can say one relation is there. How I find the value of 1 by z, that is the conjugate. Okay. In the conjugate we have the formulas like first formulas I can say here it is z1 z2 conjugate is equal to z1 conjugate into z2 conjugate. Okay. Now one more formula is there, that is what? That is, let's suppose second formula is what? Let's suppose z1 by z2 z1 by z2 I want to this whole as a conjugate. So what is the value of this one? This is equal to your z1 conjugate divided by Z2 conjugate. Z1 conjugate. Similarly, let's suppose one more formula is there. That is, let's suppose Z1 plus minus Z2 whole conjugate is equal to how much? This is equal to Z1 conjugate plus minus Z2 conjugate. Okay. So now we can represent the modulus and conjugate also on this Argent plane. In the Argent plane also we can represent this modulus and conjugate. Okay. So let's suppose I want to represent. Firstly, let's suppose I want to represent the modulus. Suppose I am interested in modulus. If I do modulus. So how to represent the modulus on the Argent plane? On the Argent plane, simply it is your, this is your x-axis, this is y-axis. Okay, let us suppose any point P is there and I want to find the modulus. How will find it? So suppose that I represent it by R. So this R is equal to under root x square plus y square. X square plus y square. This point P. This is the representation of modulus on Argent plane. Okay. Now let's suppose I want to represent the conjugate. So how to represent the conjugate? Conjugate. How to represent the conjugate on the Argent plane? Let's suppose I want to represent the conjugate on the Argent plane. So this is the x-axis, this is the y-axis. So point P is, let's suppose the point P is given here. The point P, and I want to represent the conjugate on the Argent plane. Okay, so let's suppose this is the, so point Q is a conjugate of the P. So this is x and this is y. So what is the value of Q? This is your nothing but x. So this is your x minus y. Okay, so this modulus we can represent on the Argent plane, and conjugate also we can represent on the Argent plane. Now we will see the polar representation. So in the polar representation, let's suppose in the Argent plane, I have the Argent plane, and in this Argent plane, x-axis is the real axis, and this y-axis is the imaginary axis. Let's suppose P is any point. This is P is any point, and this origin is O. Now this point P, I can represent this P as a function of Z. Okay. So this O to P, this will be how much? This is represented by, this is R, and value of this R is equal to under root x square plus y square. So let's suppose Z is any complex number. Z is any complex number, and it is denoted by x plus iota y. This is denoted by x plus y, x plus iota y. Let this directed line OP, this is making the theta with the angle. Theta is the angle in the positive direction of x-axis. Okay. So this P is denoted by, the polar coordinate r and theta. The r and theta is denoted by the polar coordinate. Okay. So where the polar coordinates are, x is equal to r cos of theta and y is equal to r sin theta. X is r cos theta and y is equal to r sin theta. So what is the value of z? So the value of z is equal to x plus iota y. So I can write it how much? I can write it this as a this is your r cos of theta plus this I r sine theta. I can take what? I can take r common, so this is equal to your cos of theta plus I sine theta. So what is the value of this r? R is nothing but this r is equal to how much? The value of r is equal to under root of x square plus y square. So this I can write it as a mod of z. Okay. But now this is theta is what? Theta is the angle. So I can write what is the value of theta. The value of theta I can write it. This is equal to argument of z. Argument of z. Okay. So how to define this theta? So for defining the theta, we have two intervals. One is your in between 0 to 2 pi and another is from minus pi to pi. Okay. So if I will take this interval, one is what? One is your 0, 0, this theta is in between 0 and 2 pi, and another one is your this is minus pi and then theta, and this is pi. Okay. So how to find this one? Let's suppose this is equal to 0 and here it is, this is equal to 0. So theta is what? Argument of z or rz. Okay. So if I take the first coordinate and the second coordinate, if I take that, suppose I am taking the first coordinate and the second coordinate. Okay, let's suppose this is the case of the first coordinate and this is the case of the second coordinate. Okay, this is let's suppose it is the first coordinate, and here it is in the let's suppose here it is in the second coordinate. So in the first coordinate and the second coordinate, okay, in the first coordinate and the second coordinate, value of theta is same. This is theta, and this is also theta in the first coordinate and in the second coordinate. Okay. Now this is what is the case of the first coordinate, second coordinate. Now let's suppose I am taking the case of the third and the fourth coordinate. Let's suppose it is here. This is the third coordinate and here it is the fourth coordinate. This is the case of the third coordinate and this is your fourth coordinate. So in the third coordinate it will be somewhere here, somewhere here. And now we will see the polar representation. How to represent this? Let the any non-zero complex number z is equal to your this z is equal to given equal to x plus iota z. Any non-zero complex number is denoted by your x plus iota y. Okay, let's represent on the RZ plane. This is the RZ plane. RZ, this is the x-axis and this is the y-axis. Okay, let's suppose P is any point. So this is P is any point function of z. P is the any point function of z. This the O is the origin. So this is your OP. This distance OP. This represented by R, and this theta is the angle in the positive direction of x-axis. So I can represent how to represent this one. Let P is the denoted by ordered pair. This P is denoted by the ordered pair. How much? This is your R and theta. This is R and theta. R and theta is the ordered pair of this one. So I can say what? I can say that what is the value of z? So this z is equal to x plus iota y. X plus iota y, or I can write it how much? R cos of theta plus R sine of theta. R I can take common, so R into this is cos theta plus I sine of theta. What is the value of r? R is equal to nothing but under root x square plus y square. Under root x square plus y square, that is equal to nothing but modulus of z. This is the value of modulus of z. And what is the value of theta? Theta is called what? Argument of z. Theta I can call it what? I can call it r z. Argument of z of r z. How to find theta? So for finding theta, we have two type of interval. One is your theta lies between 0 to 2 pi, and then theta lies between minus pi and pi. Okay. So I can divide it. I have one, or I have theta when in the first coordinate, when the theta in the first coordinate, when the theta in the second coordinate. First coordinate and second coordinate, two cases are there. So if the first coordinate, so it will be here, and what will be in the second coordinate? In the second coordinate, a point P is somewhere. So if it is in the interval 0 to 2 pi, so it is the value of theta is equal to this much theta. And in the 0 to 2 pi, when it is the second coordinate, P is second coordinate, so this is also the value is also, this is the clockwise, this is also into theta. Now, if it is in 0 to 2 pi, let's suppose, taking the next case, for the both case in the first coordinate and the second coordinate, the values are same, while in the, let's suppose, in the third coordinate, and then we have lastly in the fourth coordinate. So in the third coordinate, the theta is somewhere here in the third. Okay, so for the 0 and 2 pi, again it will be like this, 0 and 2 pi. Then for what in the fourth coordinate, if in the fourth coordinate, so for the fourth coordinate, P is somewhere here. So for 0 and 2 pi, this will be like this. So for first coordinate in the both cases, the theta is same. But for the this 0 and 2 pi, for third coordinate like this, for fourth coordinate is like this. And for 0 and 2 pi, for minus pi to pi, when this is in the third coordinate, means what? Means this point P is somewhere here. Then for this minus pi to pi, it will be how much? This will be your this will be like this for minus pi to pi. Then this is for the case of the third coordinate. Then similarly for the fourth coordinate, like suppose for the fourth coordinate, it will be somewhere here. It is in the fourth coordinate, somewhere it is there. So what is the value of that in that case? In that case, the value will be like this. Like this. Okay. In the interval minus pi to pi, this is called what? This is called the minus pi to pi. This is called the principal argument. Okay. Now we will see the solution of quadratic equation. Okay. Actually, what happened in the quadratic equation? We have this real solution. Then this is one more solution there, that is the imaginary solution. So what is the meaning of the imaginary solution? The meaning of imaginary solution is in the case of the quadratic equation, the value of b square minus 4ac is not greater than 0. In that case, we get the imaginary solution. Okay. What is the quadratic equation? Simply quadratic equation is that ax square plus bx plus c is equal to 0. This is the general equation of the quadratic equation, in which this the value of a, b and c, this is the real coefficient. A, b, c and these are the real coefficient, and your a is not equal to 0. If a is equal to 0, what will happen? It will be changed into the linear equation. Okay. Now let's suppose I want to find what is the solution of this ax square plus bx plus c is equal to 0. So let's suppose alpha and beta are the two roots. So this alpha and beta are the two roots. Then that is equal to your minus b plus minus under root b square minus 4ac divided by 2a. The solution of this quadratic equation. Now what happened in the case of this under root b square minus 4ac? This will be what? There are three cases are there. When b square minus 4ac equal to 0, then greater than 0, and then less than 0. So when this b square minus 4ac is less than 0, in that case what? Then in that case we get the imaginary solution of this quadratic equation. Okay. So I'm taking one example. That suppose I want to solve this x square plus x plus 1 is equal to 0. So what is the value of a? A is equal to, you are comparing this one. A is equal to 1, b is equal to 1, and c is also equal to 1. So what is the value of under root b square minus 4ac? This is equal to your under root a square, or that is b square, that is how much? B square is here, how much? B is 1, so this is 1 minus 4 into a into c. So a 1 minus 4, that is equal to your minus root of minus 3. Okay. So in this case, this is equal to how much? This is minus root 3, nothing but this is your root of 3 into root of minus 1, that is root of 3i. Okay. So if I put this value here as a root 3i, I can get the solution of this quadratic equation. Thanks for watching. If you have any doubt, write in the comment box. If you like the content of the video, please like it, subscribe it, and share with your friends.